We now start with ionic compounds. Bond. Ionic bond. Taken, not shared. So, back to the beginning, why do elements form compounds? The octet rule, to become stable, they each want 8 electrons in their outer shell. Sodium loses 1, chlorine gains 1, so they both end up having 8. So, let's take a look at our Lewis dots. Everyone in the first row has 1 valence electron. They want to get 8. They have a choice. They can either gain 7 or lose 1. What do you think they do? Hint, pick the smaller number. They lose 1. So when they lose an electron, it becomes plus. So electrons are minus. You lose 1, you become plus. Just like losing something negative, you feel much more positive. Second row, they have 2 valence electrons. They have a choice. They can either lose the 2 or gain 6. So lose 2. That's easy. Then there's the transition metals in between. We're going to ignore them for now. And we have aluminum with boron, and that's 3. So they can gain 5 or lose 3. They usually lose 3. So we have +1, +2, and +3. Don't forget, good way to remember is that metals are losers. They're going to lose the electrons, which makes them always positive for now. Now, how about this guy? Oh, 4. You can have 4 or gain 4. There's no short, smaller number. The answer is they do both, but these guys tend to be covalent. So you won't see too many of these +4 and -4. You might, but those are special cases coming later. So don't really worry about the 3s and 4s. But now we have nitrogen. They have 5. They can either lose 5 or gain 3. Aha! Now they have another choice. They can gain the 3, and they have 3 more negatives, so they're -3. Oxygen wants 2 more, so they get to be -2. And halogens want 1 more, they become -1. Easy way to remember, +1, +2, +3, and then start from the other end. Noble gases don't want anything, so they're 0. -1, -2, -3. The 4s meet in the middle. We're not going to see too much of them, so just pay attention to the 1s, 2s, and 3s, the -1, -2, and -3. Those are the important ones for now. Okay, so is an atom still an atom? Actually, it's not, because an atom has the same number of protons and electrons. They're now ions. Ions, because they've lost electrons or gained electrons. So they're not, now they are an ion. They're not an atom. They're an ion. Okay, so, I lost an electron. Are you positive? Yes, they're positive. Okay, so remember ionic bonds? Electrons, they're transferred from the metal to the nonmetal. Metals are losers. They become cations. Meow. Plus ions. Metals are pluses, +1, +2, +3. Nonmetals, they want to gain. They become negative ions or anions. The negative charge. So here they're meow. Sodium and chlorine. They are now ions. You don't draw a Lewis structure because they are not sharing bonds. It is an ionic bond. Transferred the electrons, and now they're just stuck together like magnets because they're plus and minus, not because of a bond like covalent bond, sharing bond. Okay, so here they, just what I said a minute ago, they're transferred, so the electron goes there. It has 8. Sodium has 8. You don't draw a Lewis structure for the bonding because they're not sharing. That's what a Lewis structure shows. Okay? Now, we're doing naming the ionic compounds. Have you heard that oxygen and magnesium were dating? I was like, OMG. Oxygen, magnesium. Ha, 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 ha. I know. Okay, so let's see if I can get myself out of the way here. A little bit. There you go. Okay, so naming a simple ionic compound. So all you do is write the name for the metal and the non-metal. So it's like say my name, say my name. So the non-metal gets that "ide" ending, just like they did in covalent compounds. So IDE is for all the endings. You don't use a prefix, you don't use numbers. All you do is say my name, "ide." That is what you do. So here's the "ide" examples. So here they are again, if you don't remember from previously. Nitrogen goes to nitride. Oxygen, oxide. Fluorine, fluoride. Phosphorus, phosphide. Sulfur, sulfide. Chlorine, chloride. Bromine, bromide. Iodine, iodine, iodide. Carbon, carbide. And in an odd case, hydrogen, hydride. So if you see them at the ending, hydrogen, it's a hydride. If it's at the beginning, it's just a hydrogen. So watch out for that troublemaker. So here's some examples. So KBr, just say my name. Potassium, bromide. Magnesium, magnesium. Oxide. CS, CAS, calcium, sulfide. Notice they all end in IDE. I'd better remember that.